So this is a short guide on how to use the OpenRocket two-stage motor configuration and evaluation tool that I created. So you're going to need two Google Sheets, a motor library sheet and an export sheet. And both of them are going to be needed to share with a Google JSON provider. The sheets I provide have this already. So first thing you're going to want to do is go to the motor library and input all of the motor designations. This is really all you need, but motor label and motor manufacturer are useful as well. And this will allow the tool to create your configurations. So what we can do now is open up the two-stage motor tool executable. And so the first thing you're actually going to want to do is scroll down to the bottom and click Check Dependencies and click Yes. And this is going to make sure that you have all of the dependency requirements for the tools to actually run. So yeah. And success. And so it's going to ask us for a few things. We're going to need a credentials JSON file, which is provided in the OpenRocket Solutions file. So we select this. We're going to need the OpenRocket file we want to modify, and this is going to create a output, which is a copy of the OpenRocket file. So our original file is not altered at all. Then we're going to need to take the motor, or the sheet ID, which is this little part between the two slashes. We're going to copy that in for the motor library, and for the export, this is so that the tools can access them, basically. We're going to select Yes on simplified format and motor lookup. What this essentially does is make it so that the only information the tool needs is this motor designation, and it can find, as long as this is entered correctly, this can be the details for the motors can be found from OpenRocket's own inventory. Okay, so now that we have that, let's run the generate motor permutations option. This generates all of the possible configurations, and it's successful. There we go. This generates all of the possible configurations of two-stage motors based on what we have here. So since we have 3 motors here, it generates 3 factorial, or 6 possible motor configurations. So now that we have these, we can import them into our duplicated OpenRocket file through this option, import configurations to OpenRocket. So we run this, and take just a second. Booster motor should be set to ignite at launch. The sustainer should be set to ignite at burnout. This is for our simulations. All right. If we go to the simulations tab, now if we take a look here, what we see our original file. Double click just has on each of the simulations that have this configuration blue reload arrow. Basically, if we look at our duplicated file first time, then just as a safety precaution, I would recommend running simulations here with this green button. This step is very important. We want to hit Control S and select all simulated data. This allows us to run the simulations with the tool using OpenRocket's simulation library. Now that that's saved, what we want to do is we want to go to the configuration tool, and we want to take a look at the evaluation parameters section. So what this is going to do is it sets the constraints for what is like an allowable motor configuration. First, this is the stability that the sustainer will launch at. So I would recommend, let's say we wanted the minimum stability calibers to be 2. I would recommend going a little below that just because of fluctuations. So let's say 1.9. And then this sets our minimum and maximum apogee that the configuration can achieve. And for testing, we'll set at 3100 for the maximum, and we'll leave 100 for the minimum. Lastly, this sample interval basically tests how fine, or chooses how finely we are looking at the how finely we're running the simulations. Basically, it'll run, if we have 0.1, it'll run a simulation every 0.1 seconds after booster motor burnout to see if there exists times that we could launch or ignite the sustainer motor and ignite at our minimum stability, and reach an apogee between these two values. For now, will set it at 0.1, but if you want it to run faster, you can set it at 0.5 or 0.25. Anywhere around there should be okay. I'm going to turn off the debug output to speed it up a little bit, but I'm also going to speed up I'm going to skip the waiting phase. It takes usually a couple minutes because it's running a lot of simulations. So I will do that right now. We'll run export configs with TC ranges. Now that we've run the export and evaluation, this is the data that we've been provided with. It gives us a list of successful configurations and the time to coast ranges that these configurations are successful for. And so I'm going to talk a little bit about what this actually means. These other values are basically just information about what the configuration is, but really these two are the columns you need. So let's take a look at configuration AB and its TC range of 0 to 2.4 seconds. So if we go into the simulation, we can set a burnout time. What this says essentially is that we can have we can launch anywhere from 0 to 2.4 seconds after booster motor burnout. We can launch our sustainer, and that'll be a successful time. So if I set 2.2 seconds and take a look at AB, we can see we achieve an apogee of about 2,100, and if I select sustainer stability caliber in the y-axis, we can see our apogee is within the range that we want it, from 100 to 3,100. And then if we look at our motor ignition, we can see that the sustainer is igniting at a stability caliber of 2, which is above 1.9, what we aimed for. But if I go in here and I select maybe a time of 3, which is not in our range of success, our apogee is still within the range we want. 1,700 is perfectly fine. But if I look at the stability calibers, we'd be launching at a stability of 1.57, which is below 1.9, and that's what the tool is telling us, that that's not a successful time. The other simulation I want to look at is CB, and CB tells us we can launch from 0 to 0.523 seconds. So if we take a look at CB, we can see it's just within the apogee limit when it's launching at 0 after booster motor burnout. But if we set this to maybe even 0.6 CB, we'd be reaching an apogee of 3,100, which is above our specified amount. And so that's why 0.5 is about the limit we can launch at to achieve a successful launch within our constraints that we specify. So that's how to use the tool, and I hope it's useful.